Hello friends, this is Raju. Today we are going to discuss about .NET rate limit. So why rate limit is important? So let's take a look one example. Suppose these are the users and this is the API. Okay. So user is going to send request to this API. Okay. This is one request, second request, third request, fourth request. This kind of user is going to send request to our API. Okay, so suppose we have hundreds of users, they are accessing our API. Okay, and suppose one user is intentionally trying to send more requests, like 1 second it's trying to send 1000 or more than that request within a few seconds intentionally. So it's created like overloaded request handling to the API server. So it's like our API server is like overloaded with all the request that intentionally someone's user sent to the server. So the problem is when server is busy to handle all the requests, our genuine user, that is our real client, they face some difficulty like delay in response because server is busy to handle too many requests that this user intentionally sent to this our API. So to avoid this kind of situation, rate limits comes into the picture. Suppose assume we set 5 requests per minute, or we can say per second. 5 requests. Suppose I set rate limit 5 requests per second only accept by the API. So suppose user send here 4 and let me send one more request. This is 5th request to the API. Okay, and suppose this user send again 6th request. This request is going to decline by the system API because we set the rate limit of 5 requests per second. So API allows only 5 requests per second. So rate limit middleware accepts only 5 requests per second. Suppose this user is sent 1000 requests per second. So in that scenario only 5 requests is going to process, rest of all the requests is going to decline by the API middleware, rate limit middleware. So this is the advantage to avoid unnecessary request by creating the user, and its process only limit of request that we send in the rate limit parameter. Okay, so let's take a look 4 types of rate limiter. These are the fixed windows, sliding window, token bucket, and concurrency. So let's take a look each type of rate limit with a diagram and coding example with test cases. So let's take a look fixed window. Let's take a look fixed window rate limit. Suppose assume we are allow 5 requests per minute. So this is our threshold limit of 5 requests per minute. Okay, so here is in this diagram I mentioned second wise like 10 second, 26, 30, 40, 15, 60 seconds. So 0 to 1 minute it's considered 0 to 60 seconds. This is the one window, this is second window, and 3 window. So this is we consider 3 fixed window. Okay, so user suppose send a request like so user send a request between 10 to 20 seconds. This is the one request. Okay, and it's successfully accepted by API rate limit middleware because threshold is not reached yet. So this is one request. Suppose user send here one more request. This is successfully accepted. Total count is 2. Now suppose user send here third. This is accepted. Fourth. This is accepted. Fifth. This is accepted. Now suppose user send here one more request. This is 6. It's going to decline by fixed window limiter because we have maximum 5 requests per minute. So between 0 to 60 seconds, suppose user send here 6 requests. So due to 5 request limitation, it's allow 5 requests, 6 is going to decline. Okay. So once 60 seconds is completed, then second window it's going to reset the limit. So again this second window it's accept 5 requests. So suppose assume user send a request here, one request here, it's going to accept successfully. Okay, then after suppose user send here one more request. Okay, so 2, this is third request, fourth, fifth. So till total we have 5 requests. So it's allow 5 requests, it's work without any issue. Then after suppose we assume this is the third window. So again in the third window rate limit is reset. So suppose user send here one more request, 1, 2, 3, 4, 5 requests. Okay. So still 5 requests it's allow. Then suppose user send one more request here, it's going to decline. Okay, so whatever subsequent request we receive, any request in this window, that all are going to decline because we reached the total threshold of 5 limit. Okay, so this is the fixed window example. The fixed window is like just it's going to reset at the fixed interval. Okay, so here we have interval of 1 minute. So every 1 minute it's going to reset the limit to 5. Okay, and this fixed window is best for login attempts. It's best for login attempts. Okay, suppose if you can see here, there is one limitation of fixed window. So if I consider here from this 30 to this 30, so consider suppose this is this 30 second to second window 30 second, it's consider 1 minute. Okay, 60 second this one is. Okay, so if I count total request 1, 3, this is 3, 4, then 7, 4 plus 3, 7, 8, 9, and this is already declined. Okay, so just ignore for now. I am going to ignore, move it here. Okay, so suppose assume these are 4, 7, 8, 9. 9 requests is going to accept in fixed window between this duration 1.30 second to 2.30 second. This is the limitation of the fixed window. So to avoid this kind of situation, it's as a like sliding window comes to in the picture. So sliding window is useful for fair distribution of the request. So let's take a look sliding window example. Let's take a look sliding window example. So suppose we are accepting maximum 5 threshold limit per minute. So this is the window. Okay, and it has like 0 to 60 second 1 minute limitation of this window. It accepts, this is the window, it accepts 0 to 60 seconds, means 1 minute window accepts 5 requests. Okay, so suppose user send request to API. Okay, this is the first request, So system accept it because this is the only first request. Then after, suppose user send here 1, 2, okay, here one more request, one more, 2, 4, total 5 requests, still not issue. Here suppose one more request received by the system, so it's going to decline by the system because we set the limit of 5 per minute. So it's accept 5 requests, this is going to decline by the system. Okay, now this window is moving forward to 10 seconds. Okay, so window now from 10 second to this second, 10 second plus 60 second. So it's here, it's moved this window from here. So this previously this request already accepted by system and it's expired because window moves to 10 second forward. Now we have 4 active requests. Okay, and window can accept one more request because this request already declined previously. So suppose any user send one more request, this system is going to accept it in its work. And suppose one more request in this duration someone send, it's going to decline because Windows threshold limit is full. Now window do not accept any view request in this duration, time duration. Okay, now moving forward. So still there we have 5 requests. There is no any expiry here. So anybody send here any request in this system, it's going to decline. Okay, so now let's move forward again 10 seconds above. Okay, so now 2 already processed request is expired, and now window has 3 active requests, so it's going to accept 2 more requests. Okay, so now let me move till here. Okay, so now this window has only 1 active request and these 2 already declined previously on that time frame. Okay, now this window can accept for more requests between this time duration. Okay, so I hope everyone is understand how sliding window works. And sliding window is useful for smoother API traffic distribution. Let's take a look token bucket policy. So suppose we accept 5 requests per minute. So this is a bucket and it has 5 tokens because we set maximum limit of 5 tokens per minute, and this bucket is reset after 1 minute. So suppose user send a request, so it take 1 token and process up again. Okay, so first request 1 token is assigned, then suppose you can send 1 more request, so it assigns second token and it's going to process. Suppose user send 1 more request, so this is also going to process. Okay, same way 4th request, it's going to process because all requests we are received within 1 minute duration. So all requests is going to process. Suppose user send 1 more request within 1 minute, but there is no any token left in this bucket. So this request is going to reject, declined by the system. Okay, so this request is going to reject. So whatever subsequent request we are received within 1 minute, all are going to rejected by the source, by the system. Okay, so now suppose 1 minute is completed. Okay, so token is going to reset, this bucket is going to fill again with 5 token, new token, because this is empty and it has maximum 5 token limit, so it's going to generate new 5 token once 1 minute duration is completed. So now we have 5 new token available. So assume, suppose user send request, it's going to assign 1 token and process for it. One more request, it's assigned 1 token and process it. And suppose there is no any request we receive, system is not receive any request. Okay, so it has 3 token, and suppose assume 1 minute is completed. So after 1 minute bucket is going to reset token. So now it has already 3 token, so now system is going to generate 2 new tokens, because it has maximum 5 token limit and 3 already exist, so it generates 2 new tokens. So this is the example of token bucket, and it is best for streaming process. Let's take a look concurrency policy. So concurrency policy, there is no any time duration. It has 2 options, permit limit and queue limit. Permit limit is at the same time how many requests is going to accept, and queue limit is suppose at the same time, suppose I send 10 requests, it's accept 5 requests plus 2 put in the queue, and then all the other requests is going to decline by the system. So let's take a look example. Suppose in this same time some system we are receive this 1 request, 2, 3, 4, 5. So here we have permit limit 5. So suppose user send 5 requests at the same time, so all requests is going to accept, and suppose user send 2 more requests, 6, 7. This request is going to in queue, so I mark as in yellow, so it's in queue. So suppose this request is completed in few milliseconds, so suppose I mark it's completed, this one is completed, so it's going to in process. Same way, suppose this request completed the process, this request is again going to the process, then one by one all the process completed. This way, or one by one all the requests completed. Okay, and suppose user send same request, like in this time 7 requests at the same time. Okay, these both are in queue. Okay, and suppose user send total 3, 6, 7, 8 requests at the same time. So 5 requests is accepted by the system because we have permit limit 5, and 2 is in queue, and this 8th request is going to decline by the system because user sent 8 requests at the same time, so it's going to decline by the system. Okay, so now this is like completed in few milliseconds, so my mark is complete, so it's this queue is going to process. This one completed, this queue is going to process for data access. So this queue is going to process. Okay, so in concurrent request there is no any time limitation, but it's handle all the requests in concurrently and manages the queue whatever we set the limit of the queue. So suppose one more example we can see here. User sent 1, 2 requests. Okay, and here user said 1, 2, 3, 4, 5, 6 requests. Okay, so here user send request, there is no any pending process available, so it's going to process, and suppose it's completed within a few minutes. I mark as like completed in within a few milliseconds, and user send 6 requests concurrently. So system accept 5 requests, this request is going to the queue, and within a few milliseconds, suppose this request is completed, this pending queue request is going to process. Let's take a look API code. So I have added here the API rate limiter middleware. Here is the fixed window limit. Okay, so I give the policy name fixed window policy. It's allow 3 requests per 10 seconds. Right now I set queue limit at 0 to get more understanding regarding how we are going to test it. That is the reason I add here 0. Later I will show you by using queue limit. Okay, so now right now I use queue limit 0. So consider this is the fixed window. It accept 3 requests in 10 seconds. Okay, and if request is more than 3 between 10 seconds, within 10 seconds, it's reject the request, and the status code is 429, too many requests. Okay, so let me run this API. So I already started this API, and I set fixed window rate policy in this controller, weather forecast controller. I added limit, and here get weather forecast method I added thread slip 2 seconds. So we it's feel like wait for 2 seconds then complete the request. So it's feel like we get data from some process. It will help us for better testing experience. So I started the API, and for testing we have to use Tailoric, okay, classic Fiddler. So I have installed the classic Fiddler. So first step is you have to copy the API URL. So let's go to the browser. So here I copy the URL of my API. This is now running weather API. Okay, so I copy the URL, go to the composer, paste here, and click on execute. So once I click on execute, see this request is completed. Okay, so our fixed window policy is it accepts 3 requests in 10 seconds. Okay, so how we can send more than 1 request in like in one time, in one go, like concurrent request. Suppose I want to send 10 requests at the same time, so we can do that using Fiddler. So click on Shift R, just click this request that we did and click Shift R. So here it's shows like repeat count, how many requests we want to send. Suppose I send here 10 requests. Okay, 10. So you can see 3 requests in queue, because it's not in queue but it's in processing. So you can see this 3 requests is completed because we allow only 3 requests per 10 seconds. Okay, So 10 second is completed, this window is reset the token limit again to 3. Okay, so let me send again. Suppose this time I send 20 requests and this is total 11. Right now this is 11 count. Okay, so after from 12 all the requests we have to consider as 20 requests. Click OK. See, 3 requests it accepted, rest of all the request is failed. So this is the advantage of fixed window limitation. So that can block unnecessary, like someone intentionally send 1000 or 5000 requests. Like suppose assume I send 500 requests. So fixed window policy accept only 3 requests, rest all of requests are failed and say too many requests in response. See, all the requests is failed except 3, this one, 1 2 3. Okay, so I hope understand, you get better clarity how we can test fixed window policy using Fiddler Classic. Now take a look one more example regarding concurrency policy. Okay, so let me stop the debugging. Now I am going to set rate limit 3, Q0. Okay, I will explain later. After this testing we can test with Q limit as well. Okay, right now I set 3 limit. Okay, so let me copy concurrent policy name and replace here. So now this controller will accept concurrency policy. So whenever any request I send to this controller, that request always go by middleware, API rate limit middleware of concurrency policy, and then after whatever request is successfully accepted by rate limiter, that request move forward to get weather forecast. Okay, so now this is concurrency policy. Let me start the API. Okay, this is our window and I already have this URL. Just click execute. So this is one request. Okay, and this is we use concurrence policy. So concurrence policy, there is no any time duration, that like fixed window just accept only 3 requests in 10 seconds, but in concurrency it accept whatever we said. Support in concurrency it's a 3 limit, it accept 3 requests. Suppose I send 10 requests, 7 requests is going to fail, 3 requests is going to process. Okay, so how we can test? Just go to Telerik Fiddler. So previous whatever I send request, just click that row and click Shift R, and I am going to send 10 requests. Okay, so based on our configuration, it accepts 3 requests, rest of the 7 is going to fail. Okay, so let me click OK. So see, this 3 request is accepted and completed the process. Okay, now let me send again 10 requests. See, 3 requests again. So concurrency rate limiter is very helpful because there is no any restriction of time bounding. Just we have to provide a limit how many requests is going to accept. Okay, so let me give you one more example by adding Q limit. Okay, suppose I add here Q2. Suppose I send 5 requests, it accept 3 requests and 2 in queue. So out of 3, suppose any request is completed, it's take request from queue. Okay, so let me start Fiddler. This is the Fiddler, send 1 request. So I select this first row, just click Shift R, and I am going to send 5 requests concurrently. So it's accept 3 requests and 2 in queue. So once out of 3, 2 requests is completed, that queue is going to process. See here, 5 requests in process, but 2 in queue. This one is queue. Now it is going to complete. Okay. So this 2 queue is also clear. Okay. Now let me send 10 requests. So in 10 requests is accept 5. This 2 is queue. It's going to complete. So 3 completed first, then 2 queue is clear, and 5 is rejected. So concurrency, I hope everyone understand how it's going to work. Suppose I send here 500 requests. See, all are going to fail. Just accept 5. Why 5? 3 we set the limit. So 3 is going to process. Then after 2. So this 3 is processed. Then after 2 is like queue. It's going to complete it. So out of 500, 5 requests is processed. So I hope everyone is understand why queue is important and its behavior, and how we can test concurrency test cases using Telerik Fiddler Classic. So I hope everyone enjoyed this video. Please share your feedback, how it is helpful in your test cases. Thank you everyone. Please add, if you like, please add comments. Thank you very much.